and the processes. Okay, so we already discussed this regarding the processors and the processors, because there is only one physical processor for each virtual process, and this is a usual case. Okay, now consider here, if you are going to design the any parallel algorithm, so in that parallel algorithm, processes are nothing but the logical computing agents that perform the tasks, and processor are nothing but we are considering the hardware unit that physically perform the computation. Okay, for that, see, in most of the cases when we are referring the processes in context of the parallel algorithm, then there is a one-to-one correspondence between your processes and the processor. Okay, so here we are considering the one scenario, one parallel computing we are considering. For with the help of that parallel computing, we are going to implement the matrix multiplication. Okay, that algorithm we want to implement matrix multiplication algorithm on a parallel computer. So in that parallel computer, okay, what we are considering, we are considering that parallel computing computer consists of the multiple computing nodes. Okay, there are a number of nodes are there for the computation purpose, and they are interacting or they are communicating with the help of message passing gateway. See, our aim is to implement the matrix multiplication algorithm on a parallel computing. Okay, so for that parallel computing, whatever the parallel computing you are considering, it has the number of computing nodes and they are communicating with each other by using the message passing gateway. Another thing is, all these nodes are using the share address space module with a multiple CPU. So for accessing the memory, they are going to use the share address space. Okay, with a multiple CPU. So that is your parallel computing. Then how we are going to be perform this, how we are going to be implement the parallel algorithm. So first thing is what, there are two key steps are there. One is the decomposition, and then second one is nothing but your mapping. Okay, so first way, so here we need to perform the two steps. In first step, what we have to consider, we have to develop a decompositions and the mapping strategy which is suitable for your message passing paradigm. Because if you want to implement the parallel programming parallel algorithm, so for the communication purpose you have to implement decompositions and the mapping strategy for the message passing paradigm, and in next step you have to develop decompositions and the mapping strategy which is suitable for the shared memory paradigm. Okay, so in this way, if you are developing these two things, then it your matrix multiplications algorithms on the parallel computing or the computations will be performed on the parallel computing. Because the scenario, what scenario we have considered for the parallel computing, जो भी system you are going to use, in that system there are number of computing nodes are there, but for the communication purpose they are using a message passing paradigm, and each and every nodes they are sharing the shared address space memory. Okay, with a multiple CPU. So for memory, this kind of uh, technique is used. Okay, so first step you have to implement, develop decomposition and mapping strategy for the message passing paradigm, and in second step you have to develop the decomposition and the decomposition and mapping strategy for your share address memory paradigm. Okay, hope you are getting this difference between your process and the processor. Now the question is remaining same, how we are going to decompose them. So as per your problem statement, according to your problem statement, you need to apply the decomposition technique. Because what happened, the decomposition technique is nothing but the fundamental step where we are considering the problem. Okay, and that problem uh, can be executed on the parallel system. So we are going to split the computation to be performed in the form of set of tasks. Okay, for the concurrent executions. Okay, so but when we are going to perform such kind of decompositions, if you are considering any decompositions out of this one. Okay, but there is a, we are not saying that there is a always a guarantee that it lead to be a base algorithm. Okay, if you are going to apply this decomposition, it is not possible every time or the always कि आपने जो भी decomposition technique use किया for your problem, okay, it will lead to the best parallel algorithm. Okay, but most of the time, okay, it is suitable or it will give the proper output for the decompositions and to implement the parallel algorithm. So what happened, because it is good to obtain the effective decompositions for the variety of the problems. If you are going to use the combinations, see, it may happen that कि अगर if you are going to use the recursive, the output will not be okay as per the expectations. Okay, so instead of that, a single type of decompositions, what you can club the two or more decompositions for the effective output purpose. Okay, and that techniques or that things is called as a hybrid kind of decompositions. So we'll see one by one decomposition in more detail. So there are, basically we are considering the four decompositions techniques. One is a recursive, then second one is a data, third one is exploratory, and fourth one is speculative decomposition technique, and fifth one we are considering as a hybrid decomposition, which is nothing but the combinations of one or two or more decompositions. Okay, well, so out of these four basic decomposition technique, first that is recursive and the data decompositions are considered as a general purpose, because as they be used for to decompose a wide variety of the problems. And in case of this exploratory and this speculative decomposition, this kind of techniques are considered as a special purpose, because they are applied to the specific class of the or special classes of the problems. See here, the a technique which is used for the special class of problem, a technique which is used for the special class of problem. So these two techniques, exploratory and speculative, is considered as a special purpose, and where recursive and the data decomposition, these are considered as a general purpose. Now we'll see the one by one. So first one is a recursive decompositions. Okay, so the name suggests recursive. It means that we want to perform the same steps repeatedly. Okay, so this decomposition is mainly based on, or in that decompositions we are going to use the divide and conquer strategy arising from the recursion. Okay, so here consider how we are going to perform the divide and the concurrent strategy for the given problem. Okay, now consider here. Okay, I'm just going to read it. Okay, so base examples for this recursive decomposition is considered as a quick sort. So we just I'm going to read now. Divide the problem into sub-problems of the same kind as the original problem, but the smaller in a size. So whatever the problem you have given, you need to divide into small parts. Okay, or we can say that the task. So each of the problem now and the sub-problem becomes a task until the sub-problems are the base problem. Okay, so the leap tasks are then solved by the specifications of the solution to the base problem. And for that example, for that recursive decompositions, I'm going to explain the quick sort algorithm. Now how the quick sort algorithm is working, actually you know about how it's working, so we'll see the examples. Okay, here, so this graph is nothing but the task dependency graph for quick sort, which having a 12 numbers total in this array. Okay, we are considering the 12 number. So how the quick sort algorithm is work, actually whatever the string is there given, or whatever the array is given, so in that one we are considering the one element Okay, that is nothing but it's called as a pivot elements. Okay, and according to the pivot elements we are decomposing your array. Okay, so for this example, suppose I am considering the first element as a pivot element. Okay, and then we are dividing your array into two parts according those elements or those numbers which are greater than which are less than the pivot number 5. So they are considered in a left side, left leaf node. Okay, sorry, left nodes. Okay, and those who are greater than the pivot elements, including the pivot elements, okay, we are considering the second right side. Okay, all elements which are present on a right side. So then again we are having this array. So again consider one of the pivot elements, and here also we are considering the one pivot element. So here suppose I am considering the 3. So 1 and 2 are less than 3. 4 is greater than 3. So we are considering 3 and 4. Now here suppose I'm considering the 9. So 5, 6, 8, 7. See, these sequences occur as per the given. Okay, we cannot sort it here. Okay, for sorting we require the again the number of steps. Okay, here जैसा sequence यहाँ पे दिया हुआ है आपके array में, it is appearing as it is. Okay, so then 5, 6, 8, 7. Okay, consider one number, first number, compare with this 9, then 12 compare with this 9. Okay, so but the private element in the right side we are considering as a first element. Okay, then 11, then 10. Okay, then again we are considering the 2. So 1 and 2 finally only are two numbers. So 1 is less than and 2 is equal to 2. So here 3 is less than 4 and the 4. So in this way we can perform the consider in each steps what we are performing these same steps, because जैसे आप लोगों ने perform किया था at initial step, we are considering the private element and we are sorting the your given array in two parts, where one array is having a less than with the private number and the second one is the greater than with the private number including the private elements. Okay, so here same steps we are repeating to solve to sort this sequence, the given array 1 2. Now this is a consider the all leaf nodes. Okay, so 1 2 3 4 5 6 7 8 11 and 10 and 11 12. Okay, so in this way you can perform the same operation at the different levels in a quick sort algorithm. So what happened, we are recursively performing the same operation, same kind of decomposition. Operation means we are performing the decomposition, considering the array, selecting the private elements, and then performing the less than or equal to or is equal to or greater than operation. Okay, so here same operations you are going to perform for sorting the numbers, okay, in a given array. So we can say we are here for the quick sort algorithm, we are performing the we are having a recursive decomposition. Now another example for the recursive decomposition is consider, that is finding the minimum of a list of numbers using a recursive decomposition. Now here suppose a given list of n numbers, suppose here, so this is the list is given. And now from that list where 8 numbers are present, so from that list we need to calculate, we need to find the minimum of two numbers. जो भी लिस्ट दिया हुआ है 8 नंबर्स का, उसमें से हम लोगों को minimum of two numbers find out करना है. So how we are going to be perform this one? Okay, so here we are making a group of two. First we are checking the group. If there are three numbers, then you need to first you need to check the three numbers. Okay, if you require the minimum of two, so in very first task you are considering the first two numbers 4 and 9. Okay, then another two numbers 1 and 7, then another two numbers 8 and 11, and lastly you having a 2 and 12. So from this one, okay, which is the minimum one, you are 4, and from this two one, which is the minimum one, that is 1. So from this one 8, and from this one we are getting a 2. Now here again two numbers are there, so from this one you can perform the minimum. So minimum number is nothing but 1. From these two 1, the minimum number is 1, sorry, 2. So here finally we are getting the our output, that is minimum number from the two minimum number from the given list. Okay. So here what happen at each steps, what you are going to perform, you are performing the, you are considering the two numbers and you are performing the minimum operation. So what you are going to do, you are having a recursive decomposition in that case also.